So for this example, I'm going to let u equal 5x minus 3. And I know that at this point, at some point, I'm going to want to differentiate it. So why not just do it now? So generally, once you've decided what you're going to let u equal, you differentiate it. And it just becomes 5. So now I can rewrite the integral in terms of u. Well, actually, carrying on with this, what I can do now is say, so dx turns out to be du over 5 by rearranging it. So I now know what dx is, and I can now rewrite the integral. So the integral becomes 4 over u times du over 5. 4 over 5 can be written as 4/5 times by 4/5. So I can take the 4/5 outside the integral and leaving me this, which is a standard integral. So the next step would be 4/5 of the integral of 1 over u du. And now that looks like one of the standard integrals. Yeah, you can do, but if you look at your table of standard integrals, you'll see 1 over u is one of your standard integrals. So now it looks like a standard integral, doesn't it? 1 over u is just log u. Yeah. And so we end up with 4/5 of the log of u du. Sorry, plus c. So finally, we replace u with what we set u to be in the first place. 5x minus 3 plus c. Let's just look back at the integral. There's a shortcut that goes on in my head. I could have written down what the answer to that was. Whenever I've got something like this, what I'm effectively doing, if we just look at this, I know I'm going to replace 5x minus 3 with u. And that if I bring this 4 outside, so I know just by looking at it that this 4 is going to come outside the integral. Because that's what's on top, the number 4. So whatever number's on top I'll bring outside the integral. I'm going to replace u with 5x minus 3, and then I know I'm going to be differentiating that. So I'm going to get du by dx is going to be, and I can do that in my head, it's just going to be 5. So I know that dx is going to be replaced with du over 5. So that 5 is going to go underneath. I know that 5 is going to go underneath. So just by looking at it, I'll bring that 4 outside the integral and the 5 outside the integral underneath. And then I know I'm left with the integral of 1 over u, which is always log u. So it's going to be log 5x minus 3 plus c. So I can write down the answer effectively. And I know, just to repeat, that the 4 comes from the 4 on top and the 5 comes from the 5 that's inside the function underneath. So just write down the integral to this. Write down the answer. Yeah, we can write down that as the answer. The minus 3 on top comes out and goes on top, and the 6 that's inside the function goes underneath. As easy as that. Because I know that when I differentiate 6x plus 2, I'm just going to end up with 6. Finally, I can simplify that, can't I? To get what? Minus a half log 6x plus 2 plus c. Yeah. And if you get an integral like that to do, I've no objection to you just writing down the answer if you're happy with that technique. But you might want to just check it by going through the steps, mightn't you, if you're in an exam situation. However, if you did these a lot, you'd do it. And incidentally, inverse function, these are inverse functions effectively, 1 over a function. And when I integrate that function, I always end up with a natural logarithm function, which is to do with, it's the logarithm of the natural number, isn't it? E to the something. So that's generally where these functions that involve e come from. An integral of a inverse function. We find them all the time, formulae that involve e, and they generally come from something like this. Integrating. Okay.